As you can see, I have mapped this Pixelp example project into Perforce, and I have a list of all the files and assets inside it. You can see it's the projects, and then we have the content and all of the subfolders existing with all the assets. And you can see that if I find a specific asset, I can right-click it and choose Check Out and hit OK. And this means that this file is now locked to my computer and my user. That means that no one else can touch this file while I have it checked out. It will pop up a, you can see we have a red marker on this one. If someone else has checked out the file, you will see a blue marker, and you will also see a preview of which user has the file checked out. So this is a very good way to work. You check out the file, you do the changes you want to do to the file, and then you submit it by hitting Submit, and you get a list of all the files you have checked out. You write a description of what you have done, and then you just submit, and the file is back. If you need to reset the file because you made a change that you don't want to keep, then you can just right-click the file and hit Revert, which will revert the file back to how it was before you checked it out. Now, this is how you use source control inside the Perforce application itself. But it's also possible to do it directly inside the Pixelp interface. I'm just going to launch this example project inside the editor right now. And we're going to see that we can enable source control directly inside the application, and Pixelp will, in turn, communicate with Perforce and allow you to work with your files that way. So now we are inside Pixelp. And if I go to my content, to art, and by the way, this is based on our style guide. So our folder structure is set up so that we have the main project name, and then we have defined various different collections, such as where we put our materials and where we put our assets. All assets are located under art. Then we have subfolders in the art folder, such as characters, environments, and props. If I jump into props, we can find, for example, this air conditioner here. You can see we have inside that folder all the material instances and static meshes, as well as the textures for that specific static mesh. So what I can do in order to enable source control inside Pixelp is to go to this button. It's called Source Control, and select Connect to Source Control. You can also do this by just right-clicking any of the assets and hit Connect to Source Control. And we're going to choose the version of source control that we use. In our case, it's Perforce. Let's give it a second. There we go. And you just map this to the server where you have your Perforce depot located, and select the workspace that you want to work with. Just accept settings, and we are now connected to source control, which means that right inside the Pixelp interface, I can now right-click an asset, go to source control, and I can check out the file. And now this file is once again locked to my computer, and no one else can touch it until I choose to release it. So I can once again check it back in, give it a description of what I've done to it, and then submit. I'm not going to do that right now because I've actually not made any changes to it. And you can also right-click it and hit source control and revert if you haven't made any changes to it. And revert. And say if you have multiple files checked out, you can also do that. Right-click all of them and choose Checkout. Go to source control, and you can submit to source control just like we did in Perforce. Then you can write the description and submit all the files you want to submit. All right. So this is very beneficial to use when you're working with multiple artists on the same scene, to make sure that no one is doing double work, basically, working on the same assets and making sure that everything is nice and clean. I'm going to revert this file because I haven't actually made any changes to them. So I strongly encourage all of you to get a source control application if you are going to work on a big project. And we're not going to dive into multi-machine setup today, but it's worth to note that if you're using source control, it's also very good to use for a local multi-machine setup. For example, if you're running Pixotope on, say, 4 machines, and you're running the same project, you don't want to go through the hassle of having to manually copy over the entire project to each machine each time you make a change. With source controls enabled, you can just make changes on one of those computers and just re-update it and resync it on the others. And you do that inside Perforce by just selecting the root folder and hitting Get Latest. And it will make sure that you get all the changes that everyone else has checked in. All right. Let's see. Yeah, I think that's about it regarding source control. And then just going to jump back into our slides. Now, let's talk a little bit more about PBR, real-time mindset, workflow, and how you should import your files, and just generally things to be aware of when working with source assets. So what does it mean to have a real-time mindset? It basically means that you have to keep in mind that when you're working with Pixotope, you are working with a real-time engine. Pixotope is built, it's a custom version of Unreal, and Unreal is, in a sense, a game engine, which means you have to kind of think like a game artist when you're creating your assets. And that means that you have to adapt your modeling workflow to how you would create an asset for a game engine. Same goes with how you do textures. We're going to dive into how to do texture baking, and you need to make sure that you have UVs. For example, if you're going to do light maps, you need an extra UV slot for the light map. We're also going to talk a little bit about physically based shading, which is what Unreal uses, in this, and by extension, Pixotope, which uses a metallic roughness shading model. We're then going to talk about, after we prepare the assets, we're going to talk about how we import and manage them. And we're going to dive into how you should structure your materials inside the projects. So let's switch this up a little bit and jump into Blender. And by the way, none of this is going to be software specific. This is just my software of choice. But when you work with assets for a real-time engine, there are 2 key things you want to think about. One is, of course, the quality, and 2 is the performance. Of course, you want an asset to look as good as possible, but you also want it to run as good as possible, which means that making sure that the asset looks good is only half of the equation. If an asset looks good, but it's not optimized, then it might degrade your performance. If I jump into wireframe mode here, you can see that we have a high resolution mesh right here of this fire hydrant, which looks pretty dense when it comes to the poly count. This is not an ideal asset for Pixotope or any real-time engine because it's way too dense. Obviously, computers are getting better and better now, and they can handle more and more geometry and more polygons. But if you were to duplicate this asset multiple times inside a scene, maybe you want to have 100 different copies of the same assets, it's going to degrade the performance. So what we want to do when we're working with when preparing your assets for a real-time engine is that you make sure that we get all of this high resolution detail, but we don't want to deal with the extra polygons. And we do this by creating a low resolution version of that mesh. You can see this one has a lot fewer triangles than this one, but it also has way fewer details. So how can we get the benefit of the good performance that we get from this asset, but with the added visual fidelity of this one and all the details without having to degrade the performance? We use something called texture baking. And texture baking basically means that you take the high resolution detail of the high resolution asset and you project that onto a texture of the low resolution asset. You can see that both of these two have the same poly count, but this one has a lot more detail because it's baked down from this high resolution asset. And if I jump into edit mode of this, you can see that it doesn't really have that much detail inside the geometry, but the texture gives the illusion that there is more detail here. And what's most important to think about when you create assets is that you look at the silhouette. Because for the most part, the only thing that's going to matter when you create assets is the silhouette. If you can't see anything in the silhouette, which you can see that the high resolution version of this now and the low resolution version, they look pretty similar in the silhouette. There is not much difference. And this can kind of give you a clue that, okay, if I can't see it in the silhouette, then it doesn't need to be part of the geometry. It can be baked down into a texture. Because obviously you want to have the extra micro detail, but you don't need to have extra geometry in order to show that detail. You can easily just have it on a flat surface as a normal map. But this is also greatly going to depend on, is this a hero asset that's going to be very close to the camera? Is it a background asset that's going to exist in the background? You kind of have to kind of figure out how much detail do you want to keep for the geometry and how much detail can you get away just by baking down into a texture. For this one, you can see that we have baked down the detail from the high resolution mesh to the low resolution mesh, and the finished texture asset has the finished texture onto it. This one, particular one, was textured inside Substance Painter, and you can see that you can add a lot more micro detail just by adding more texture detail to the actual surface. Now, I'm going to actually show you that process right now, how you can bake down high resolution detail. I'm not going to go into depth how to texture an asset because that's beyond the scope of this webinar, but I'll just show you the process just so you can see what the hell I'm talking about. So we're going to use this Studio Light asset that we have here. And I'm going to select this parent right here. You can see that we have two versions of this asset. We have the low poly and we have the high poly. What we want to do is to take the high poly asset that has a lot of the nice detail. You can see that this one has a lot of the nice smooth beveled edges on every surface. It makes it look more smooth and realistic. If we jump into the wireframe mode, you can see that it's actually a lot more dense than this one. This one is the one that's optimized, the low poly version. And if I, let's see, jump into edit mode, you can see that it doesn't really have all of those nice smooth bevels that we actually want to see. So what we want to do is to bake down the detail from this high resolution asset onto the texture of this, using something like Substance Painter, like I'm going to show you right now. It doesn't really matter what software you use for that. You can actually do this directly inside most of the 3D packages, but I'm just going to use Substance Painter for this demonstration just because it's a very nice software and it's what we tend to use in-house. So I'm going to put this there. Another thing to think about when you need to bake these assets is that you need to make sure that they are exactly on top of each other. In this case, I have the studio lights both existing on the same place. Disable the low poly one, we can only see the high poly one. Disable the high poly one, enable the low poly one, you can see it's existing exactly the same place. And you want to do this because when you do texture baking, it basically takes and projects the detail from the high poly one down onto the low poly one. And make sure that this detail gets projected onto the low poly one in the correct places. So you want to make sure when you create your low poly version of the assets that you want, of course, to be as low poly as possible, but you don't want it to lose volume. You need the volume to be approximately the same as the high resolution mesh so that you don't have any weird things happening when you bake down detail. You don't want the detail from this particular part to be baked down onto another part because it's too small. So yeah, just keep that in mind when you prepare your assets and make the low poly versions. This is, like I said, not going to be an extensive tutorial on how to use Blender or Substance Painter. But since we're using Substance Painter, just keep in mind, for those of you who are interested, for Substance Painter specifically, you can split up your asset when you export it to Painter. In this case, you define the high poly one with a suffix of high, like _high. This means that this is the one that Substance Painter will use to take the high resolution detail. And then you have the low poly asset, which has a suffix of low. And we've split up all our assets the same way. For example, you have lens low. This is this part. This corresponds to lens high, which has the high resolution detail of this lens. Which means that you can just export this entire asset as one, and Substance Painter will be able to split it up based on all of these suffixes. So how you would do this is of course going to be specific to the software of your choice. But you just hit export as an FBX, and you give it a name. For example, this is the low poly, so we're just going to call it LP for low poly. And you just hit selected object, make sure you only export the selected objects from that low poly version. And you just export that. You do the same thing with the high poly model. Make sure that you only select the assets that you want to export that into a new FBX and call that high poly, for example. Now, let's open up Substance Painter, so we can see how we actually do this baking process. Just give it a second here to load. All right, there we are. So I'm just going to open up a new project so we can demonstrate this baking capability. And select the file that I exported. In this case, it's the low poly version of this Fresnel light. Select that, open. And then I'm going to define the texture resolution, which in this case, I'm going to use 4K because we want to have a lot of crisp, nice, high resolution detail to the textures. And we're just going to hit OK. So you can see we get the low poly version of our assets. as well as our UVs. So now we just have the low poly version. It doesn't look very detailed. We don't have those nice smooth bevels, and we want to bake those down from the high resolution model. To do this in Painter, you just go to Texture Settings, Mesh Maps, and Bake Mesh Maps. And under Common, just select High Definition Meshes, go into your folder structure and find the high resolution model. And then you can change the max frontal distance, max ray distance. This is just basically just the basically just an offset of the model of how far you want Substance Painter to look, basically project the detail to. But the most important one, like I talked about how you split up the asset with the subfixes, is to make sure that the match setting is set to by mesh name, which means it will utilize the subfixes that we set up inside Blender. And you can, of course, change this if you have another subfix. You can change to something else, maybe high, you can say HP or LP for the low. Doesn't matter. By default, it's set to high and low. And you can just define all of these different textures. And all is looking very good. What I like to do the first time I bake is to set the output size to a pretty low texture size, just so you can bake it fast and just see if everything works correctly, or if there's anything that we need to fix inside the model itself. So when I'm done, I'm just going to select Bake, Showcase Mesh Maps. In this case, the name of the material is Showcase. So it just is going to tell you bake this material. Let's select this. And you can see that Painter is going through the baking process. Give it a second here to finish uploading. Oh, looks like we had a little bit of a mishap happening here. Let's try that again. All right. So I'm just going to go through, really quickly go through the same process that I did before. Opening up the assets. Go to my texture set settings. Find a high resolution asset. Make sure it's matched by mesh name. And just going to try to bake. All right, it looks like we had a bit more success this time. I'm just going to hit OK, and now Substance Painter has finished baking the textures. This was pretty easy, right? It was pretty automated process. So I can see that it doesn't look like there are any major artifacts on this model right now, except for the fact that it's really low resolution, which means that I'm happy with that. I can go into my texture baking settings again and set this to the resolution that I want to bake it to, in this case 4K. And I'm going to bake this again. This will obviously take a little bit longer because it's high resolution. But this is a pretty simple asset, so it shouldn't take too long. As you can see, it's also baking all the different maps that it kind of needs to texture stuff, such as the normal map. The normal map is basically the bump detail that you get from the high resolution mesh. And then it's also basing some other clever maps such as ambient occlusion and curvature, and I will kind of show you what these look like and what they do. Yeah, just give it one more second to just finish baking the final maps. And here we are. Now you can see that we suddenly have a lot more of that nice smooth detail on the edges. If I go into my Let's see. Just going to move my interface a little bit so I can actually see what's going on here. Okay, so if I enable wireframe on this, you can see it's still the same low resolution model, but now we have that nice bevel detailed on these edges. That makes them look a lot more realistic. And once again, this is all just part of the textures that we baked. I look at the UVs. This is the UVs that the textures are baked to. And if I hit B inside Substance Painter, I can toggle between the various maps that we just baked. The ID is basically just a way that you can mask your various different meshes if you need to do that. I didn't set this up, so it doesn't really show anything useful. And then you have the ambient occlusion, which is now baked down to its own nice map. Next, we have the curvature, which is kind of defining the the sharp edges, which is very good in Substance Painter for defining places where you want to maybe put in some wear and tear. Then we have position and thickness, and most importantly, the normal maps. The normal maps is what's taking the high resolution detail and putting it onto texture and giving you the illusion that this is a much more detailed asset than it actually is. It's basically kind of faking the normal detail by adding more normal detail on top of the actual normals of the mesh, and then distorting the light in those places where we actually don't have that extra detail, but the normal map is adding that extra detail in. Looking realistic assets. So I'm just going to jump into my resources here. So let's see if I can find my finished textured assets. Just give me a second. And boop. Let's give it a second to load. This one has some high resolution textures. And you can see it looks pink. So this is just because this was made in an older version of Substance Painter. So we just want to make sure it's using the updated shader. Most likely it's using the curvature map to define that these areas are the ones that are going to receive most of that wear and tear. So very cool stuff. Now, this is using a PBR shader, and that is also what Unreal is using. So that's how you should texture your assets using a PBR workflow. So what is PBR? A lot of you artists are probably already familiar with this, but it's a very important concept to have in mind. So I'm actually just going to jump into some documentation here from APAC up regarding physically based shading. So there's some very good documentation on the Unreal Engine documentation regarding physically based shading. I encourage you all to read up on this if you are interested, and just if you need to know the kind of the science behind physically based shading. But how you basically can break it up is that physically based shading gives you a very streamlined way of defining your surfaces. And you can break this down to two main parameters. And that is being whether a surface is metallic or dielectric. And dielectric means basically it's non-metallic. So you have either metallic or non-metallic surfaces. That's how you can basically break down every single surface. And it's set up with material parameters so that you only have a few settings that you need to adjust in order to make a realistic looking material. And this being the base color, the roughness, the metallic value, and the specular. So the base color is obviously the colors themselves. The roughness defines how rough a surface is, or an invert of that, how shiny it is. The metallic obviously defines if a material is metallic or not metallic. And then you have the specular, which defines the strength of the reflections themselves. So once again, I encourage you to take a look at this documentation on PBR shading. There's a lot of documentation out there talking about the science behind this and why it's so useful for us artists to use. But if we jump back into Substance Painter, we can see that we have defined all of these surfaces inside these textures. We only have one material applied to it, but we have multiple surfaces within that material. So for example, I can just make a new texture and I can define in that texture all the different surfaces, such as color, height, roughness, metallic, normal, and emissive. For example, the base color is obviously the color itself. The height is where you would add in more bump detail in addition to the high resolution normal map that you've baked. For example, in this case, let's see, in this case, you can see that we have added extra micro detail to make this surface look more realistic. And you can do that using the height to add some more bump detail in addition to the normal map that's baked. Next, you have the roughness. I'm actually just going to set all of these to pass through so we can actually set all of this to replace, sorry, so we can actually see what each of them is doing. Let's set all the channels to replace. There we go. Emissive, and set it to replace. And this basically just allows me to override every single thing that's underneath it. I just can demonstrate this. In the height, you can define the height values, but it doesn't really have anything in it right now, so it doesn't really do anything. But if we put in a texture to it, you can find maybe one of these grunge detail, maybe, no, procedural. Let's use one of these procedural textures. I can add, let's see, if I add this, for example, this fractal, maybe not that one, this fractal noise procedural texture, and add that directly into the height channel, you can see it's now giving some extra bump detail on that surface using this procedural map. And we can scale up the detail a little bit, make it look a little bit more realistic. Set this to triplanar projection, so it actually doesn't use the UV seams. And just give it a bit more scale. And you can see that we have some more details. And we can maybe take down the intensity of this because it doesn't look that great. So I'm just gonna move the interface a little bit around because it's a bit hard to work on one monitor right now. But I can basically just go into my specific height channel and take down the intensity. Actually, this might actually affect the normal channel as well. So I'm just going to take down the intensity of that. You can see when I take down the height channel, it's actually taking down the details intensity. Stuff like this, you want it to be pretty low. You can see that I have it on 1% right now, and I'm still seeing a lot of that detail. But bottom line is, this is basically how you can add extra detail without having to actually model it. Let's see. Next we have, where's my, there you go. So we have our different properties. We looked at the height, which we attach a texture to. Then we have the roughness, and the roughness defines, you guessed it, how rough the surface is. Give it more roughness, the surface will be more and more diffused and less reflective. And if I bring it back to 0, the asset will be more shiny. And this will be more apparent if I just remove the height map that we created, because it kind of breaks up all the specular light that we're receiving. Now we can see that it's actually a pretty shiny object because we set the roughness to 0. So if I increase this, we can define how rough the surface is, basically. And you can also do this by texture maps, obviously. You can use a black and white map to define where the black areas are the most shiny and the white areas are the most rough areas. Here we have the metallic value. And like I talked about before, a material is either metallic or it's not metallic, meaning that this value should, for the most part, it should be either on or off. Right now it's off because it's at 0. If I put it to 1, you can see we get a surface that looks like a chrome metallic surface. There might be a few cases where you need to kind of fake things, because even though this is physically based shading, it's not going to work for every single case. Sometimes you have to go in between, but this is a very rare case. Usually you only have to define either if it is metallic or if it's not. The use cases where you would define this as something in between would be where you need a material to be kind of, it is for example, it is a metal material, but it started to rust a little bit, or it started to kind of change its surface. So in this case, we can define that this is a metal material on the bottom. Then we can add a new layer to define where the rust is. So I'm just going to, let's see. If I just apply this rust material, you can see we have this rust material, which is a non-metallic material. And then I can mount this out based on, once again, a mask. So just add fill. Once again, I'm not trying to go into detail about Substance Painter. I'm just doing this to demonstrate how PBR materials work and how you can define your surfaces. Okay, so now we have defined that we have the metallic material and showing through, and then we have the rust material on top of it, which is not metallic. Okay, very cool stuff. So let's see, now we have our finished textured asset. And we need to make sure that we have this prepared so it can go into the Pixeltop engine. And inside Substance Painter, you can set various export settings to define which maps are exported. If I hit C, I'm just going to resize this a little bit. If I hit C, I jump between the different channels that Substance Painter has combined and will be exported. For PBR shading, you have, like we saw, the base color, which are the color values. Then we have the height values. The height values are actually not going to be exported as a separate value. This is actually going to be combined with the normal values. Then you have the roughness, which defines black as the shiny surfaces and white as the rough surfaces. And anything in between will be either rougher or shinier. Then we have the metallic surface, defining whether if a material is metallic or not. You have the normal map, the emissive, which is actually, in this case, what you want to be used as an emissive material. Then you have normal plus height mesh, and this gives you the ability to combine, well, actually Substance Painter does this by default. It combines the height detail that we added inside the software with the high resolution detail that we baked. And this is what we will export. So if we go into the export settings, you can set up the various export methods. I'm just going to quickly set up a new one so we can just see what's going on and what we recommend doing when packaging together your texture maps. Let's see, I'm just going to duplicate this one so we can actually use a preset that's already there. But what you want to do is that obviously this is going to be specific to your style guide. So just give it like the prefixes and suffixes of your style guide and how you need to define our textures. And then you define which channels you want to export. For the base color, you obviously need the RGB values or the colors, and then you might need the alpha if you have an opacity channel. For the roughness, you need a black and white image. In this case, you take the let's see, where's the roughness? There we go, roughness. Then you just drag it over and define it from a gray channel. And this will export the roughness into that. But we don't want to export every single map into just one file. We want to be able to package it to a more compressed and more optimized way. So what we can do is that we can take and set it to R plus G plus B, which will split up the channels. And based on our style guide, we put things into what's called an MRAO map, which packages the metallic map and the roughness map, as well as the ambient occlusion map into one file using the 3 color channels. So since we have the metallic first, we put the metallic into the red channel as a gray channel, and then we put the roughness. Let's see, what's the roughness again? There we go, the roughness into the green channel, and then the ambient occlusion into the blue channel. And this means that we get 3 texture maps, but only 1 file, which is going to make it more organized and more optimized. The normal we want to export as a single file because the normal map needs the color values in order to define the surface, and the base color also needs RGB values in order to define that. So let's say we have exported all of this. Let's jump into the Pixelop editor so we can actually see this in action. So let's see, I'm just going to check my note here a little bit. Right. Just going to actually close down Substance Painter and Blender in the background, so we're actually not losing performance. Just give me a second here. Yep, we get all of our performance focused on Pixelop and not anything else. Right. And by the way, I talked about style guides and project structure. We're going to just kind of enforce that while I'm working on this. So we're going to import that studio light that we just saw into the correct folders. I'm just going to go into content, Pixel exterior, art, and this will be a prop because this is a small asset and therefore it's defined as a prop. I'm going to jump into prop. I'm going to create a new folder, call this one studio light. And this is where you would put all the assets related to the studio light. So I'm going to drag in my, hang on, I'm just going to find the correct assets. Okay, so this one is actually not named correctly. I'm just going to name it correctly just to enforce that naming convention and folder structure principles that we talked about. So we have the low poly version that we created. I'm going to name it s_studio light. And then you define which version of the studio light it is. In this case, it's a Fresnel light. Fresnel. And this is how you define static meshes. I'm just going to drag that into the content browser. And we get some various export settings. Now, not a whole lot of these you need to worry about, but the most important ones are if you have a mesh that has multiple elements in it, and you want to import that as one single static mesh, you need to make sure that you combine the meshes. You want to make sure that you import the normals. And you do not want to create materials because you want to usually want to set those up from scratch using the shaders inside Unreal. You don't want it to kind of guess how the shaders, or try to build them automatically from the shaders you have in your 3D software, because it doesn't really always work that well. So I'm just going to choose do not create materials and do not import textures, because we'll do that manually. And if you have selected multiple FBXs, you can choose import all in order to import all the assets at once. In this case, it's only the one asset. I'm just going to hit import. Just give it a moment to load in there. And it's also worth noting that Pixeltope supports Python. So import can also be automated if you have a specific script that's doing that. This is taking a bit longer than it should, but just let us give it a few more seconds to load. This is probably because this is a pretty heavy project to begin with. It has a lot of assets already in it. Come on now. Okay, so I'm just going to try to restart the editor now, see if we can get this to run faster. I'm just going to go into director and close the level, and it will close it for us. I'm going to launch the editor again. Let's give it a couple of seconds to load. And once again, just as a reminder, the first time you add your projects, it will take a while to load the project, but subsequent times will be a lot faster. Like you can see right now, it should be up and running a few seconds now. We probably have a little bit of performance issues right now because obviously I'm running multiple softwares And it's probably eating up our VRAM because I've been using Substance Painter, I've been using Blender to demonstrate various aspects of this. And just give me a second here to get the scene ready. All right. So we have a little bit of a, let's see. There we go. Okay, so I'm going to go back into my Pixup exterior folder, back into props. And you can see that it has at least kept the Studio Light folder that we created. So once again, drag in the static mesh that we created. Make sure that it has combined meshes enabled. Do not create material. And it has kept all the settings that we selected before, which is very handy. I'm going to choose import. And let's hope we have better luck this time. Right. So I'm not exactly sure why it's struggling with this specific assets, because it shouldn't be this heavy. Just for testing, we're going to try to just do a clean level and see if that helps. I'm just going to have to open the Pixup exterior level first, and we're just going to create a new level inside the editor. Okay, so this. All right. I'm just going to jump into Pixup exterior. And for levels, you have a specific folder called maps. This is where you put all your levels. I'm just going to create a new level here using, once again, naming conventions from the style guide, typing in level underscore, and we'll call this something like, I don't know, plain level. And we actually use camel case letters for this. So capital P, capital level. And because we're using source control, I'm also going to select source control and then mark for add. And this is what you do when you make new files. You mark them for add, and then you can submit them when you're finished with them. Open that up. So we have an empty level open. Let's see if that helps our importing a little bit. I'm going to jump back into the props folder, find the Studio Lights folder. And we're going to drag in the same Actually, I believe why this happened. I actually renamed the wrong file. I actually tried to import a higher resolution one. This is why that happened. I tried to import this one. That's the one I renamed. That's why it probably was so heavy. So I'm renaming the low poly one now, dragging it in. And it has once again kept all our settings, which is good. Hit import. And it worked. So that was just me being careless. Sorry about that, but at least now we got it in. And we get this message saying no smoothing group information was found. This is fine. This is just specific because we use Blender, but it should look correct. Once again, we're going to add this to source control, mark for add, and we can open up our asset. So inside this asset browser, you can see we have the low poly version of this model, and we have the one material slot. This one also has UVs for the texture, and it has UVs for the light maps. And we'll talk a little bit more about light maps later on. But since we have this asset in here now, I'm going to open up the Quickstop exterior level again. And here we are. And now we can start to drag in our textures and start to focus on our materials. So let's just drag the studio light into the scene so we can actually see it a little bit better. And we're going to start to define our materials, and we're going to talk about material structure and how this should be set up. For a complex project like this, where you have hundreds of different materials, you need to have a proper hierarchy for them, both for cleanliness and for optimization purposes. So if I go into the folder called Material Library, this is where we have all our master materials. A master material basically defines what kind of properties do you want in these surfaces, and which properties do you want to expose to the artists who are going to work on tweaking the materials themselves. We have a couple of master materials here. The most common one that we use is called M_MRAO, which is the metallic roughness and ambient occlusion channels that we talked about. If I open this up, you can see this is a normal shader inside Unreal, which has all the defined properties that we need. This is actually not a material that we're going to apply directly to any asset. This is just like the template. So what we want to do with this master material is to only expose the parameters that we want the artist to be tweaking. In this case, we have diffuse strength, and we have metallic min and metallic max. This is just like a threshold between the two. And then we have roughness, occlusion values, as well as a specular value. And emissive strength, because this studio light actually has an emissive map into it. So we have your master material, but you want to be able to have some materials on your actual assets, right? So what you do then is to right-click and then create material instance. And a material instance is a lighter version of a regular material that gives you a lot better performance and real-time ability to tweak the various aspects of the shader. So for this, in terms of naming conventions, we want to make sure that it's named properly. For material instances, our style guide is using MI and then underscore this studio light and then underscore main. We only have one material for this. And so we just call it main. And the reason why we want to use mass materials and material instances is because regular materials has obviously a lot more draw calls, and material instances will remedy that. So we put in our material instances inside the actual assets folders themselves. The master materials you want to keep inside the material library. That's where you kind of keep the library of all the templates and all the masters. But the instance itself, we're going to put this into our Studio Light folder over here. By the way, if you hit this handy button, you get a hierarchy of all the folders inside your project. I'm just going to drag it over and choose Move here, which means it will move it away from this folder and put it inside the Studio Light folder. So now you can see we have our material instance and our Studio Light static mesh. By the way, if you hit the view options, you can define how this preview is going to look. You can actually select this thumbnail edit mode, and you can define how you want your thumbnails for your various assets to look. The material as well, you can actually switch the preview surface of that material if you desire to do that. Orbit around it, around the surface, and you can do the same thing with static meshes. Just a nice little quick tip. So if I open up the material instance, you can see that this looks very different from the actual master material. And this one has way more properties than actually should be there, because this one is set up to use the weather system that we have showcased before. But really, the only properties that is usually available in this master standard MRAO material is the scalar parameter values here, where we can tweak the various surfaces, as well as where you put in the texture maps. So I'm going to put in textures that we exported from Substance. Well, let's pretend that we exported anyway. So let's see here. I'm going to drag in my, once again, sticking to naming conventions, we have the texture maps with the prefix T for texture, and then the suffix for what type of texture map it is. In this case, it's D for diffuse. Sometimes you use diffuse or base color. In this case, our style guide uses diffuse for that, so just underscore D. And we have the normal map, which has underscore N, and then the 3 channels that we packed into one has the MRAO suffix. So we're just going to select all of them and drag them into the editor. You're not going to get any import settings when you import textures. It's just going to be directly imported in there. And if I open up the texture itself, you can see that we have the texture map available to us. Now, the diffuse channel usually will come in as it should be. And I'm not sure why I'm not seeing the menu here. Maybe one of my colleagues can actually help me out with this. Why I'm not seeing the menu on the side of this map channel. Let's see, window and details. There we go. So when you import your texture maps, it's going to give it a compression setting. And you can, of course, change this. For a color map, you can use the default DXT compression, because this is a color map. But it's a little bit different when it comes to the other channels. For example, the normal map needs to be set to the compression setting of a normal map. And Unreal, and by extension Pixtope, is very good at recognizing if a material is a normal map, or a texture is a normal map or not. So it's very good at recognizing, because it looks at a normal map has this very distinctive look where it looks with this kind of a purple and pink and blue values. So it will usually recognize that. If it doesn't, you just set it to being a normal map. For the MRAO material, it's not going to recognize that as anything specific, because it's basically just all the 3 maps packed into one single file. So you can see the red channel has the metallic value. The green channel has the roughness value. And the blue channel has the ambient occlusion value. And with these packed together as color channels, it looks pretty strange. Sometimes Unreal will misinterpret this as a normal map, but that's all fine. You can just change it. In this case, we want to set it to masks. Means that it will not use an sRGB compression. So just set it to masks, and it will make sure that you get the uncompressed black and white images from the masks. Okay, you guys still with me? I know there's a lot of information to take in. I'm going to add these to my source control. Actually, also important to remember to save often. Control S to save, or just hit save all, and you'll get the list of all the things you want to choose to save or not save, basically. So we're going to apply this material to this light. For props like this, it's best to apply them inside the asset itself, because it's usually just the one material you're going to use for it. or you can just apply it directly inside the level. Sorry, I'm just going to actually scroll down so you can see that a little bit better. We have the material slot over here, and we move the material over to the material slot and apply the material. This will only happen inside this level. So if you want this to be more permanent and happen on every instance where you're dragging the assets, you just apply it to the actual asset itself and then just save. So now we have the material applied to it, and now we need to add our texture maps to that material. I'm just going to hide these so we can get a better overview here. So we want to apply the diffuse map to the diffuse map channel. Now you can see we already get some colors on this. We want emissive map. So this is the lens, the emissive map for the lens that we have textured inside Substance Painter. And we just drag that to the emissive channel. The metallic occlusion map, where we will put the Amarillo material. And then we have the normal map, drag that in. We have these extra maps here for snow surface and such, but we're not going to touch that now. That's just specific for that weather system that we have in this scene. So inside the material instances, you can see the parent, which in this case is the master material Amarillo. I just want to quickly show you that when it comes to the metallic roughness and occlusion material, you can see that we're using the 3 RGB channel, and it's split up into the various different parameters and then piped into their respective channels. In this case, metallic roughness and ambient occlusion, which is over here. And that basically means that when you add your texture map to the ambient occlusion, roughness, and metallic map to this slot, it will automatically just pipe in the different channels into the right surface parameters. Okay, so now we have applied all our textures, and you can see that we now have the textured asset rendering very nicely. But the emissive part of this, it doesn't really have any emissive value. It does have the emissive map, which is just kind of the mask for where you want to define where it's actually doing the emissive parameter, but it doesn't really have a value. So we can set the emissive strength to, for example, 1, which means that it will just display it 1, or we can increase this one to much higher value and make sure that we go to director and enable some nice looking gloom. Now we can see that the light is actually getting bloom from that emissive channel. Very cool stuff. Very nice, very nice. Okay. Let me just check my notes here a little bit. Right. So this is kind of the process how you would do it with a small prop like this. But what about larger assets like buildings or like we've seen before with our studio asset? I'm just going to save all of this. I'm just going to kill the complaints. It doesn't disturb us here. And we've saved everything, so it's going to be back here when we go back into the editor. I'm not going to save the level. And I'm going to open up Blender again. All right. So this is the process I just talked about is specific for this small prop. But if you have something that's a little bit bigger, the process will be a little bit different. Because of a large surface like this, you're limited to the resolution of your textures, and for large surfaces that might not be enough. So for something like this, you will need multiple materials for each defining surface. And each material can have its own 4K texture. In this case, this house is split up into various materials based on the various surfaces. In this case, you have the walls, which are kind of the wooden walls. You have the roof, which is a very large surface that needs its entire 4K texture on its own. But usually for large assets like this, you might want to actually use more tiling textures and not bake it down to one single texture because the surfaces are too large. And I'm going to show you how this looks inside Pixel, but first let's just talk a little bit about the UV maps. So you can see this one has multiple UV maps. Usually you only want 2. So I'm just going to split this area. You can see I'm going to jump into the UV editor and jump into edit mode. Let's see. So you can see the first UV map has a bunch of different things overlapping because this one has multiple materials. So I can just split this up based on material so we can see this a little bit better. So if I select this roof, for example, you can see we only have the UVs for the roof. But once again, this is combined. The overlapping is only happening because we have multiple materials. But the light map, let's see. Okay, so this one doesn't actually have a light map. So let's see if we can actually just create a new one. Just an old asset. So now we have the texture UV slot. I'm going to duplicate that. So now we have a copy of this one. We can probably name this one light map. Oh, didn't actually do it. Oh. Anyways. Let's see. Okay, it doesn't allow me to change the name. That's fine. Okay. So it's exactly the same. But since this is just one mesh that has all the materials in it, it's fine because it's split up into materials, but the light map uses the entire asset. So you want to make sure that all the UVs from all the materials are packed into one UV slot without any overlap. So if I pack this, give it a second, and make sure there is enough padding between all the UV islands so we don't get any nasty overlap or artifacts when we do the light baking. And this will still keep the texture UVs intact. If I go back to the texture UVs again, you can see that they are intact here. If we go back to the light map UVs again, you can see that they are intact. Very cool stuff. Now, I'm going to jump back into Pixel again. And we're going to show how you can deal with breaking up tiling textures. Let's see. All right, let's see. To hide this text so it doesn't disturb us. Just going to hide the comp plane. Okay. So once again, for these large surfaces, like for example, this cobblestone ground, you can see that if we go into the material for this, let's see, now restore, go into the cobblestone material, you can see that this is a very basic material consisting of this very uniform cobblestone textures. And this is usually what you would do with a large surface like this. You can't really like crank up the texture resolution to 4K and expect it to look sharp because the surface is so big. So how you can break this up is using something called decals. So decals are basically a way to add extra detail onto surfaces. You can see we already have some in this scene. If I move this around, you can see that I'm moving the various dirt spots on this cobblestone material. Move this, we have some painted lines here that goes on top of the material. And this is basically how you can break up the repetitiveness of a large material like this. Let's see. Did I forget anything? Let's jump quickly back to the slide deck so we can see if we have anything or we talk about. I think that's it for today's webinar. If you have questions regarding any of this workflow stuff, feel free to ask during the Q&A. And I mean, if anything was unclear or if there's anything you are particularly interested about these workflows, then just let us know and we'll go through it during the Q&A. And, you know, we'll have some fun with some questions. So we're going to take a 5-minute break now and allow you all to collect your questions and ideas, type them in, and we'll make sure to answer as good as we can. And don't worry if you haven't had a question written down. You can easily just write down your questions while we're answering them as well. Keep them coming. Keep the questions coming. And we'll see you all again in 5 minutes, which is now 11:29 local time. So we'll see you all again back in at 11. Okay, just switch to 11:30 actually. So we'll see you all back again at 11:35. Okay, hope to see you all again in 5 minutes. But now to just make sure that you are all back, and feel free to continue to ask questions. Just put them in. Okay, I think we can begin. Let's see these questions. Okay, so the first question is, I would like to have the vendor spec file. Yeah, we will forward this after the webinar. So, let us know if you want this spec sheet example, and we'll send it to you. Next question, does Pixtope support all source control options on the market right now? For example, Bitbucket or with SourceTree. All Pixtope ships with plugins for Git, LFS2, Perforce, Plastic, SCM, and subversions. But any plugins that work for Unreal can be compiled for Pixtope, basically. Are you using plugin to retopologize objects in Blender? I haven't used that specifically for the scene that I showed or the props that I showcased, but you can do that. Could we get the reference sheet guide? Should we email? Yes, absolutely. Just get in touch and we'll send it to you. By the way, a follow-up explanation for that question regarding the retopologizing the objects. This one was just basically modeled by hand based on the higher resolution model. And for a very, let's see if I can just get my interface way here. Oh, give it a second. It's a very dense, high resolution mesh here. I'm just going to turn off this house. Okay, so this one was just basic. This is a very basic prop, so it was just kind of modeled by hand. We didn't need to use any retopologizing to get this to work. But for more complex assets, or for example, character models or more organic models, obviously it's better to use some retopologized objects. And there are, of course, many plugins out there for this for Blender, if you are interested. Next question. How to manage object with constraints on import? You cannot combine meshes. I'm assuming that with this you mean that constraints such as when you can parent objects to various things, and you can use modifiers to kind of like, how to say it, you have like this one, you have this one parented to a dummy object that moves the entire thing, then you have constraints for the various objects. And I believe in, for example, in Cinema 4D, you're using a lot of constraints to kind of define your various models. Everything is parented into a nice hierarchy. And for FBX export, it doesn't really keep any of those constraints. It only keeps the meshes, I believe. So, but this is going to depend a little bit of how you bring in your assets. Bringing in your assets as FBX files is only one way you can bring in assets into Pixtope. The newest version of Unreal supports Datasmith, which gives a dynamic link between software such as 3ds Max and I believe Cinema 4D Don't hold me on that, but basically it's a dynamic way where you can have a dynamic link between the 3D package and Unreal. And this will also be available in the next version of Pixitope. Okay, next question. Hello, you mentioned the process of baking texture for geometric optimization, such as normal maps, but you did not talk about baking diffuse, baked shadow, etc. I suppose because in a PBR workflow and the power of the Unreal system, there is no need anymore to bake light shadow. Can you give some more explanation in the future, if it's not already done, of the process of the light baking? Okay, so this is kind of going to be kind of a two-part question, because one, yes, if you need to bake things like bake diffuse or bake the shadows into diffuse, like you say, you don't really do that because the PBR materials are basically not utilizing baked shadows. We're using baked ambient occlusion for this, just to give some added extra detail to the sorry, give some extra nice smaller ambient occlusion detail. But that's specific for assets. When I talk about light baking, I'm referring to the light baking happening inside the entire level inside Unreal. And for this, we can bake the global illumination and the ambient occlusion and all of that into maps inside Unreal for the entire scene. And that's what you use the light maps for. So this has nothing to do with the process of baking down detail into the assets, but it's a process of baking down the lights from the scene inside Pixitope. And we will go over this more about light baking on Monday's session, when Frank is going to show you how to optimize your scene and talk more about lighting and light baking. Next question. Does Pixitope support Megascan plugin? Well, it supports Unreal, so it means by extension it will support Pixitope. So I believe this is all for the questions. Thank you so much for sticking with me today and learning about workflows and such. We're just going to talk about what's going to happen on the next session. The next session is going to be on Monday, and I'm going to hand you back over to my great colleague, Frank. And he's going to talk about how you can optimize your scenes, as well as lighting, light baking, more about reflections, and more of that ray tracing goodness. He's going to talk about the Pixitope render pipe and the overhead, video playback, and he's going to finish up with showing you how you can optimize a bad performing set. So I hope you all look forward to that on Monday. And I wish you all a very nice weekend, and we hope to see you all again on Monday. So thank you so much for watching, and we'll see you again very soon.